Hello, this is Bruce Lee from South Korea, and I'm currently studying at the University of Pennsylvania and doing a research on automatic readability analysis in collaboration with an educational tech company named LXPER in Seoul, South Korea. A few months ago, we have introduced our first model, LXPER Index, not through a conference, but through a paper. And now we present to you the second version of it here at the NLPT workshop. And I'm very honored to have this opportunity today. So let's begin. Let's begin with some introduction. And when you really look at the title of our research, the first question that would come to your mind would be, what is text readability analysis? Just what is it? What is so interesting about it? And text readability analysis is an important area of NLP since 1940s. The technology enables the convenient selection of appropriate reading material for readers with different levels of proficiency. And this characteristic makes the technology really important and really useful to these educational use, where teachers have to deal with students with varying level of proficiency in English. So it has been one of the most important, not most important, but one of the important areas of NLP since 1940s. And since then, more than 200 readability formulas were developed. So what is the problem? Why are we starting this research again when there are already 200 readability formulas out there? So what is the problem? We see three problems. First of all, since most NLP research workflows was in the English-speaking countries, most research focused on the native audience in English-speaking countries like United Kingdom, United States, these type of countries. And however, in China, Japan, and Korea, many high and middle school students attend English language schools, right? And in addition to their regular school classes, they attend these English language schools. And furthermore, English subject plays an important role in the educational systems of the three countries, potentially having an impact on the college admission processes as well. And according to research, uh, there is a $3 billion market out there in Korea, and even a bigger market in Japan, and probably even bigger market in China. Uh, so even though there is this big of a market and this large number of students trying to learn English, the previously developed readability assessment models that we had until now don't work well in the situation of L2 students trying to learn English. Because even though there's the same English text, the view and understanding from an L2 student and the view and understanding from a foreigner, from a native student could be drastically different. Thus, to our knowledge, since this traditional readability assessment models they simply have very bad results in L2 English text, not many L2 English educational institutes use such automated readability models. And now we're going to actually present to you our research. However, before we do so, I want to summarize some of our contributions so that you can really follow them while we present to you about our research. First of all, we are going to introduce curriculum-specific linguistic features. The key distinction between the native readability assessment and L2 readability assessment is that L2 students mostly follow the specific ELT curriculum. So we strongly believe that we can reduce the average assessment error by implementing these curriculum-specific features. Second of all, we utilize and expand context, one of the few greater corpora with text from an actual L2 curriculum. And just going back to the start of this research, we started researching LXPER index to really just test ourselves how accurate of an index that we could make with a limited amount of resources, because we were trying to make an English text readability assessment program, but then we want to make it specific for L2 students, but then it also had to be specifically for the curriculum L2 curriculum, Korean L2 curriculum. So it was really difficult to find the texts that fall into all of those three categories. So we really had to struggle with a limited amount of resources. However, it seems to be a success in the end. So yeah. And third of all, we compare our LXPER index with other readability assessment models. And towards the end of the presentation, we are planning to show significantly improved accuracy compared to the other existing readability assessment models. We also compare LXPER Index 2.0 to its predecessor and prove that grades are better modeled using logistic regression, but not linear regression. Corpus. First of all, our base corpus. The base corpus that we use is named Cockett text, which is the same corpus that we used in our last research. Uh, last research, and our last research actually contains much more information about this specific one. So you can check it out if you're interested in the corpus itself. And the corpus used to be, when it came to us, it was a collection of 2,760 unique grade level texts that were officially administered by the Korean Ministry of Education. And the big problem with this corpus was that the number of texts included was highly skewed to the upper grade level, thus possibly causing issues with the regression techniques that we were using. Second of all, the new expanded corpus that we have, put some upgrades to the base corpus that we were given, really focused on collecting more of the lower grade text. How I have told you beforehand that the base corpus that we were using was very highly skewed to the high grade levels, to the upper grade levels. So the process that we were really trying to do here was really bring down the skewness and make it as balanced as we could. And the important point here was that every single text had to be some form of government approved or officially administered by the Ministry of Education. And by keeping this criteria, we can really make sure that our index is really, really custom trained to the Korean ELT curriculum. And the texts are used in the National Assessment of Educational Achievement, places like college scholastic ability text, or even from the Ministry of Education approved middle school textbooks in Korea. So we really have to scrape as much as we could to build a corpus. And this is the end result, the original one that we got, that we obtained from on the left, and the final one that we are using on the right. So even though it still seems a little skewed to the upper grade level, you can see that we've tried as hard as we could to bring down the skewness. But we do agree that the corpus is still skewed to the upper grade level, and that is something that we would have to tackle in the future. And moving on to the linguistic features, we have about 30 linguistic features that we use to analyze a text when it comes to the LXPER index. And those can be really divided into 5 parts. And the first four, traditional POS, entity density, lexical change, of course, we've put some novelty into these features as well. However, these are the types of features that you will see in most other readability indexes that were developed recently. So I'm gonna skip on this four. And the one that I really want to introduce to you is the last one, the word difficulty features. So the Kokek word, so in order to make this into the real life and really implement this into the models, we actually had to build a separate word corpus where we would actually classify over 60,000 words from the current ELT curriculum into 6 levels of difficulty. This was a very difficult process, but in the end, it saved some life. And we'll check out how our new novel features play out in the readability. And the parsing counting feature selection, so when it comes to the code, it could really be divided into 4 libraries that we use. First of all, first two were SPACY and LTK, used for the most basic but important tasks. These were the 2 very trustworthy libraries that we could, really trust that these libraries will do the job. And second of all, we used Benepal, which is the Berkeley neural parser, to pick out the POS tags from a text. And this is the constituency parser, and this is also one of the top ranked open source parsers. So we decided to go with Benapar, and the last one that we used was something that could be excluded, uh, but it was quite useful for generating lexical chains. However, this lexical chains this can also be very easily generated through custom coding. So I would say that the use of Gansim was not very necessary in this case. So this is what we got in the end. So you can see when you look at the yellow rectangles at the top of the column here, you can really see that some of our word difficulty features played out really well. There's D-level words, B-level words. However, on the other hand, this lexical chain related features played not so well in this table. The lexical chain, the entity, entity, entity. However, if you think about it, what previous researchers has been saying a lot about the L2 readability assessment was that the lexical features and entity features would come into as very important factors when it comes to readability assessment. However, here you can clearly see that it's not the case in this research. And we actually do think that it would not be the case for the other L2 countries as well. So and one of the shortcomings of those previous research was that they didn't actually use a corpus from a real L2 curriculum. So we believe that that could be the reason why as to they led to a false, wrongful conclusion. But this is something that we would have to prove in the future as well. And the second point, uh, the curriculum specific features like the word difficulty labels that we have implemented, these were working very well in predicting the target grade level. So when it comes to L2 readability analysis, the curriculum specific development is the way to go. That's at least what we believe. The point three, the POS tag features still serve as good backbone features to readability assessment. And yeah, I still do believe in this POS tag features. And yeah, I believe that POS tag features would be something uh, that would be very inadmissible even in the future implementations of this program. Now, moving on to the last part of our presentation, the test and evaluation. First of all, the logistic regression model. We use this model for LXPER Index 2.0. And we built a logistic regression model and trained it with a new expanded version of Cookie Test to complete our assessment tool. Our model is programmed in Python. And we use a very popular library, actually. We use scikit-learn, a popular Python library for data science and machine learning. However, we believe that similar results could be achieved by using a different library or self-program code because after all, it's the same regression techniques and the principles behind it. And second of all, I want to introduce our test corpus. The first part of it was 270 official mock tests that were used by this institution named KAIS, which is the Korea Institution of Curriculum and Evaluation, to assess the educational achievement of high school students from 2017 to 2020. So this was 270 tests. And the second part of our corpus was from the government-approved middle school textbooks, 90 texts each grade. And by the way, 90 takes each grade for the upper part as well. So combined gives 540 government-approved texts for that corpus. And this is our result. Our result was better than what we had expected. From left to right, Flash Kincaid, Dale Shaw, LXPER Index 1.0, LXPER 2.0. And you can really see that if you see the exert table down below, you can also see that the only index that performed, that showed a constantly increasing trend according to the grade was LXPER Index. So yeah, we didn't really have a lot of time at the end of the presentation, so we really had to wrap up. very quickly. So that is one shortcomings of this presentation, I guess. However, I do believe that I have at least delivered to you the most important concepts in this paper, and I also uh, do hope that many of you interested in our research could look it up on the archive or Google to really look up for our researches. And I'll be really grateful if someone would do that. Thank you so much.